Anywho, William, hey buddy, you get your little xforce straight 6, and it has been slightly modified. I'm not gonna lie, some of the things I see inside of these things just blows my mind. Multiple people have been inside of this box, multiple different technicians, and it came here because it kept dying. And William sent it up here because he's tired of burning up pills. And out of the 6 pills that were in this thing, he had a dead one here and a dead one here. And his input combiner was all screwed up. The other thing he said is that it was so far out of tune that when he tried to run this box on his Moonraker, it would make his SWR jump way up. Which I believe it, because this 160 puff disc capacitor is what the output tuning circuit was. And this thing rates 86 puff. So I replaced that with slightly higher kVA and very flexible capacitance tuning tube. The other thing that we did is we went in and we removed all the DEIs that were in this and put a matched set of 6 Toshibas in their spot. And as I was sitting here looking at it, you know, when this came from xforce, it didn't have these 3 extra, it had these 3 power supplies in it. Somewhere along the line, somebody has added a 4th, which is not necessarily a bad thing, but by adding this here, they had also added this piece of phenolic here. And they do that to, I guess in theory, shield or give a place to put caps or something. I don't know. There's a downside to that. I cut away a piece of phenolic that was as big as my finger. And I cut another piece of phenolic board away that was as tall as my finger. Well, if we get down here and look, it was touching the top of the cabinet, and so was it here. So it means all the cooling, and I did the same thing over here. They had notched it out for this little ground strap, and I cut this off here. So now if we look down here, we've provided a space for the air to move around and flow back down and around and out. Now, the upside to this, William, is that this has got the wide heatsink to it. And if you were to get this same cabinet today, it wouldn't be, the heatsink wouldn't be as wide. It would stop right about here. So you've actually got a big old hunk of aluminum underneath your transistors. And it's long too. If we get down here and look, it runs almost all the way to the back of the cabinet, which today they now stop right here. Of course, this is a straight 8-pill cabinet or board. So I don't know if they were just doing, I need a board and a cabinet, and they put this in here that day. I don't know. But the end of the story is that it's right. The airflow is blocked off here. Instead of trying to make all the airflow crawl across this little tiny slit across the top of the cabinet and then down across the heatsink, we created a path of less resistance to where it funnels around here across the top of the components and across the final combiner, across the top of the components, out, give it a pathway so it can wrap around and properly exhaust. That way the air doesn't lose a lot of its velocity, therefore it can still efficiently pick up heat and transfer it to the air and exhaust the heat out of the cabinet. A lot of the problems he was having, I have a picture of it, not one single DEI was the same lot number, which doesn't necessarily mean a whole lot as long as all the gains are matched. But I can tell you that over the years, nobody's pulled all the transistors out, checked all the gains, and then beta gained them all and put them back together. Oh, this pill's gone bad. To replace a 10 ohm resistor and to replace a transistor. So now you have a transistor with a lower gain in the same push-pull circuit as a transistor with a higher gain. This transistor is going to fight this transistor and drag this one's gain down, meanwhile dragging that one's gain down. That's why he wasn't getting very good life out of it. Upgraded power supply, that's a good thing. Adding all this copper phenolic so the air can't flow across the parts, bad thing. Having DEIs in it, bad thing. We're going to take this box all the way out to its max. We're going to test this puppy today. We got the fluke tied in here so I can show the voltage. We're going to use a 1000 watt slug and 1X and PEP. That's where we're going to start. We're going to bury that thing in a corner. 1000 watt in average, 5 watt slug and reverse. We're going to use the Connex 3600 HP and the Striker 955 HP with a 5 watt slug between it and the amplifier to start. Then we're going to wind up using the Connex, drive a 2-pill into this, which is a whole bucket load worth of drive, but I want to prove a point. That if the box is set up properly and it's got the proper amount of volts behind it, these things are almost bulletproof. It's the beauty behind the Toshiba part, as I think we all kind of know. But don't tell anybody, be our secret, okay? Me and my almost 2,000 viewers. All right, so let's start. We're idling at 15.29 volts. Come up here and grab the mic for the 955. Pedal. As you can see, I'm easily laying that in a corner. Let's run the carrier up a little bit. Let's watch our voltage in the output power. What? Stays above 15. That's pretty good. They usually fall platform on their face and they drop down below about 14 volts. So it's telling us it's got more than adequate amount of power supply in it. Let's go up here and look at our input tune. Which is beautiful. Absolutely beautiful. Okay, we're gonna go up and drive. So I'm gonna cut away for a second. We're gonna put the tin on this thing real quick so we can get some airflow around some parts. We're gonna drive the whole bejesus out of it and see if it blows up. It probably won't. Actually, I know it won't. We'll drive the snot out of it and see where its peak power is at. Be right back. Hey, real quick, before I put the lid on it, I'm just hitting this with the Connex. We're going straight through the 2-pill. And I wanted to double check my numbers. So that's our average meter, peak meter, right? And this is our input voltage. It's about 14 and some change, right? Let's look at our average. So we're seeing roughly 6 out of it. Uh-oh. If we go over here and we do the math, 6 times 2.2, 1320. Now, let's do that again. Because I was reading a newer study, and a different way of figuring the absolute peak power is 6 times 2.40. And the reason they're saying for that is because you have to allow for more distortion and overall field growth. I like 2.2. It's a lot more conservative. I'm conservative in the numbers. I don't want to get all carried away. But according to that, we should see 1440. So we know that we're in the ballpark. We're seeing roughly 1400 over here. We're seeing roughly 600 over here. We take those rough numbers, and remember, these are just gauges. They give us a rough idea. You can't sit there and Uger Wattmonger. The guys that do, I feel sorry for them. But this gives us a rough idea, and this also gives us the ability to double check our peak meter versus a Bird 43 with absolutely nothing in it. It's just a straight 43. So 600 times 2.4. That's one of the later studies I've read. I also noticed that in the amateur radio general test, that this is now part of one of the questions in the pool. Notice that too, and that is the number that they recognize, 2.4. Anyhow, enough of that tire. Let's get on with this. Let me put the tin on it. Okay. So we're on the Connex. We got the lid on it, and now we got laminar airflow. I've been sitting here playing with it. And that's the FLIR. And you look at the FLIR, you can see that tight heat spot there to the right. That's the line of fins that the transistors are all sitting on top of. I've been sitting here keying this thing off and on in between the little cuts in the video. Look at how quickly it's exhausting the air, because now it's got laminate airflow. Now we could increase the volume of air with like a blower. I got another xforce 6-pill here that a guy has had me put a blower on it. Because he's one of these guys when he keys on it. Well, you know, Jim, I got up this morning, brushed my teeth, and I started talking on the radio, and yeah, you know, he sits there and he's keyed down for a long period of time. We wanted to build him a box that could support that, so we put a blower on it. But the point that I was getting at is that's dropped several degrees in just the last couple minutes, and we haven't even really started standing on it yet. Is that if you got good components inside your box, they don't break down at low temperatures. It's that simple. Hello. And we're swinging about 120 watts ish into this thing from the Connex. Let's see, we'll put this on standby real quick. Hello. 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 Well, that was entertaining. Look, the lid's back off again. A new little fault in this box came out while I was shooting the video. I hadn't tried to talk through it yet. So this is the old relay out of the amp. I put a new one in there. Let me explain to you why. So as the RF comes in, it comes in on this post. As you can see, somebody has cut it. As the RF comes in, it travels along this wire, goes across this tab point. Well, when the relay is in a resting position, the RF comes through this top pin, translates through this top pin, comes out this wire, and goes through the preamp circuit and comes back out and goes back over here. But how it goes over there is it goes through this tab and down here and out this pin. Now, I first thought it, man, it probably has a dirty contact, but if you look real close, because the guy that was in here before me soldering away on stuff got the pin too hot, and the tab moved up and shorted out the relay. Well, file that one where it needs to go, and I'll put the tin back on it. We'll get on with a quick test. Okay, so now we've completely reset at this point. We're going to demonstrate drive of the Connex. Hello, audio. Hello, audio. Hello, audio. Just under 100 watts. So with that 100 watts swinging, we're going to kick it into a 2-pill, kick it into a 2x6. Okay, I got the Connex going into 2-pill, going into 6-pill, 6-pill's off. Hello, audio. We're swinging about 300 into it. As you can see, I got the variable down on the 2-pill because I don't want to drive the holy bejesus snot balls out of the 6-pill all the way just quite yet. Turn that on, turn the sideband delay on just because we don't want to hear the relay chatter just in case. That's about a 400 watt dead key. Hello, audio. Hello. Seeing what, about 1800 out of this? Hello. And right around 800 average. Hello. We're going to go ahead and turn this all the way up. Hello. 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 Seeing 1900 peak out of this, driving it balls out. Look at how hot that got. Look at that. And now that we got the proper kind of airflow, it's going to slowly start cooling off again. Just saying. Anyhow, guys, my name is BBI. William, 6-pill's fixed and it's done right. Put the rest of the screws in it. I'm going to go ahead and put warranty stickers on it because I've been all through this thing. And I know that they're not going to back up the warranty, and then the other two guys that you've sent it to already, they're not going to back up their warranty. I will give you another warranty. I will take on the liability of this box. I will guarantee everything in here except for the transistors. Well, for as long as you own it, William. End of that story. So you're going to have a warranty sticker here and another one over here, bro. My name is BBI. And without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out. www.bbiamps.com. And I don't get to do this without all of you. That's a fact. I don't get to be here unless you guys subscribe. And I don't get to be here unless you guys send in your projects for me to repair. So do that. Take that little box below it and make it read subscribed instead of unsubscribed. And follow along. Call me up on the phone. I'll help you get back yourself 10.8 and get running straight again. I appreciate it, you guys. I really do. I see you.